So the formula for the half angle sine theorem is over here on the left side that I just highlighted. The problem number 12 has you to try to find the sine of theta over 2 if you know that the sine of theta is 2/3, but notice that the formula requires you to find cosine. So presumably if you've already done the sine of 2 theta and the cosine of 2 theta, you may have already done the cosine formula. The cosine, if you haven't, we can use the cosine identity, the cosine squared theta equals 1 minus sine squared theta, and then replace the sine squared theta with, since we know sine of theta is 2/3, replace that with 2/3 squared. So you have cosine squared theta equals 1 minus 2/3 squared. Then you simplify that, so it's 1 minus 4/9. And 1 minus 4/9 is 5/9. And then to simplify that, you would need to do the square root of both sides, which means it's the square root of 5 over the square root of 9, which is the square root of 5 over 3. And then you can take that into your formula and replace the cosine of theta with the square root of 5 over 3. So it becomes everything under a square root, 1 minus the square root of 5 over 3, all over 2. And probably the quickest thing to do on this one, the easiest thing, would be to eliminate the complex fraction by multiplying times the square root of 3 over the square root of 3 underneath the radical sign. Not going to change a whole lot by putting it underneath the radical sign. And what that does is it will cancel out. You'll distribute that 3 with the 1 and the square root of 5 over 3 and with the 2. And so that will give you, all under a square root, plus or minus the square root of 3 minus the 3's cancel, so it's just the square root of 5. So those 3's cancel, that 3 cancels with that, and 2 times 3 is 6. Now, that technically means that you have the square root of 3 minus the square root of 5. And yes, I know that looks weird that there's a square root underneath the square root, but that is perfectly okay. All over the square root of 6, so we need to rationalize the denominator by taking it times the square root of 6 over the square root of 6. And this also looks a little weird, but this is the way you would write it. It would be the square root of 6 times that square root of 3 minus square root of 5 all over 6. Now, I suppose if you really wanted to, you could distribute that square root of 6 into here, but there's really no reason to because trigonometrists don't really do that a whole lot. So that is the answer, but we still got that plus or minus that's been hanging out in the front of there, so that doesn't mean it's plus and minus. It means that the answer is either going to be plus or it's going to be minus. So in the original problem, it says that we are dealing with theta between 90 and 180. So if theta is between 90 and 180 and we're doing a half angle theorem, half of 90 to 180 means that theta is going to be between 45 and 90, or that half of 90 is 45, half of 180 is 90. So between 45 and 90, that's quadrant 1, and sine is positive in quadrant 1. So what that means is going back over to here, that the answer is going to be only the positive solution and not the negative solution. So I will just erase that negative out. And so the answer is positive square root of 3 times square root of 3 minus the square root of 5 all over 6.